Welcome to Lido Learning's question and answer videos. My name is Pallavi and I teach maths and science at Lido. Let's have a look at this very interesting question in front of us. That is, a cyclist doubles his speed. So let's say this is our happy cyclist moving with speed v, and over here our same cyclist has changed his speed to double, that is 2v. This is the speed. Okay, let's say this is the speed and here 2v is the speed of this particular cyclist. Okay, let's read the question again. So a cyclist doubles his speed, then how will his kinetic energy change? So we have to see what will happen to the kinetic energy, whether it will increase, whether it will decrease, or whether it will remain the same, right? Okay. Before going to kinetic energy, we should all know what do we mean by energy in general. So energy is the capacity of a body to do work. So energy is the capacity to do work. Its SI unit is joule. Joule is the SI unit. It is also written as J, right? Okay. Now let's move ahead with kinetic energy. What do we mean by kinetic energy? So energy possessed by the body due to its motion. So in both these cases, the body is moving, right? That is, the cycle is moving. Therefore, both of them have some kinetic energy, right? Let's say, since it is the same cycle, because here he has just double the mass, double the velocity of the, or double the speed of his riding of cycle, right? So let's say we will say that the mass of the cycle is same. That is, mass of the rider and cycle both will be same, m, because he is riding the same cycle. Only the speed has changed. Okay. Now let's define how do we express kinetic energy. So kinetic energy is expressed as half mv square, where m is mass of the body, v is the velocity of the body. Let's write that down over here. So kinetic energy is equal to half mv square. M is mass, v is velocity. Now let's look at case A first. So case A, let's calculate the kinetic energy when the cycle is moving at speed v. So kinetic energy is equal to half mv square, because mass is m and speed is v. Okay, let's have a look at case B now. So we are looking at case B where the cyclist has doubled his speed. So the kinetic energy for B, let's say this is kinetic energy for A and this is for B. So for B it will be half. Now mass is again same because he is the same rider, he is the same cycle, he is having the same cycle, so mass doesn't change. Half m, but here the velocity has become 2v, right? 2v square. So we see that half, let's solve it further, m into 4v square, or this cancels out with this, so it becomes, or let's not cancel it. In fact, then it will be easier to tell what will happen to the kinetic energy, right? So over here this will become half m, and there is a 2 square, so it will become 4. Let's keep it outside. So 4 into half m v square, or 4 we will keep it outside, half m v square. This is kinetic energy of B. Now half mv square was kinetic energy of A, right? So kinetic energy of B is 4 times kinetic energy of A. So clearly the kinetic energy has increased when the cyclist has doubled his speed, and it has become 4 times the previous kinetic energy. So kinetic energy has increased. This is the answer to this question. I hope all of you have understood this. If there is any further questions, please post your comments below. Thank you.